So in this video, we're going to take a look at a low power concern we had with an ML400. Now, we've driven this car and it does appear to be down on power. Now, having said that, we don't have much to compare it to because we don't get to work on a lot of these ML400s, but it's maybe not quite as powerful as it should be. Having said that, the car does seem to pull okay, which would indicate to me that we're not dealing with plugged exhaust or any of that kind of stuff. So it is down on power, but it's not what I would consider to be massively down on power to the point where it won't rev out. It will rev out. It'll go to 5,000, 5,500 RPM, that kind of stuff. And it pulls, but it doesn't pull as strongly as it should, in my opinion. So we're going to start off here. We're going to go ahead and take a look at it and see what we've got for code. So when we go in and look at it, look at the codes, this is what we've got. We've got a P008A, pressure in the low fuel pressure circuit is too low. That's a stored code. We do have a current code, P02430, an electrical fault exists in the low pressure turbocharger output. I'm not exactly sure what they're referring to there. We have a stored code for P0299, boost pressure too low, and then we have a timing code as well, P001177. The turbocharger code, the 299 code and the 243 code are the two that interest me the most. Given that the 243 code is current, I think we need to start looking at the turbocharger, just to make sure that it's making good boost and that kind of stuff before we get too far involved in looking at anything else. So I think the next thing we're going to do is we're going to just take this car out, we're going to hook the scan tool up to it, and we're going to go and collect some turbocharger data. So we got the scan tool hooked up. We're going to go in and configure it up so that we can look at some scan data. Basically what we want to look at here is intake manifold data or boost data. I'm not sure how they'll classify it on this car. Mercedes does it different ways with different cars. So we're going to let the scan tool ID the car. And now that we're in, we're going to go ahead and select drive. From there we want motor electronics. We're going to select live data. We want engine output. And then finally we're going to take boost pressure control. Now there's a fair amount of data here. We don't want it all. So what we're going to do is we're going to go through and we're going to pick out the data PIDs that are relevant to intake manifold pressure and boost. And then we're going to arrange those so that we're just looking at the relevant data. And then the next thing we're going to do is see what this car does on a road test. So this is a snapshot of the vehicle at wide open throttle. You can see from the inlet manifold pressure pit, the top one, that this thing's sitting at atmospheric pressure. Now when the throttle is closed, it should be under vacuum, which means the pressure should be lower than 14. And when we're under boost, it should be higher than 14. So we've got our foot to the floor. Even though this car is pulling well, it's only showing atmospheric pressure. And when you look down at the boost pressure, it's not making any boost, or it's making very slight boost at the very most. So what we've got here is a situation where under wide open throttle or even part load, this vehicle is not making boost. So we need to go in and take a look at what's happening with those turbochargers. So this is a slide from one of our training classes, and I use this to kind of explain how the turbocharger is controlled in this particular vehicle. So what we have is a vacuum pot wastegate, and the wastegate in this particular instance is spring-loaded open. The vacuum to the wastegate is controlled by a solenoid, which is pulse width modulated by the PCM in the car, and then vacuum is supplied by a vacuum pump. Now on this particular car, as soon as the vehicle is started, the vacuum pump is turned on, produces some vacuum, and the computer turns on the solenoid, and that allows vacuum to go through to the wastegate and close it up. So the vehicle is all set to perform or to make boost right out of the gate. And what happens is, or what's supposed to happen anyway, as boost builds in the system, the computer starts to bleed vacuum away from the wastegate, opening it up and slowing the turbocharger down. Now on our particular car, this thing's not making any boost, so we need to go in and take a look at the vacuum system on this thing and see exactly where the problem is. Now possibilities are the solenoid, something wrong with one of the wastegates, or something simple like the vacuum pump is not producing any vacuum. But that's where we're headed with this vehicle. So the next thing we're going to do is we're going to hook up a vacuum gauge and start checking the vacuum system. So what we're going to try and do here is a couple of things at once. We're going to check and make sure the system is producing vacuum, and then we're going to see what happens to that vacuum when we go under boost. So we're just teeing in a vacuum gauge here, and then we're going to drive the car. So this is our road test with the vacuum gauge hooked up to the right side turbocharger. It's not really making a whole lot of vacuum, which would not sure what that means yet, but we're less than 10 inches of vacuum here, which doesn't seem like a lot to me. In a second here, we're going to jump on this thing and see what it does. Now we know the car's not producing boost, so let's see what it does when we step on it. The minute we step on it, the vacuum goes to 0. Okay. And I'm going to assume that when the vacuum drops to 0, that's when the underboost code sets. So we have a problem with vacuum to the turbochargers on this thing. So what I'm going to do is I'm going to get out and I'm going to change my vacuum hose over to the vacuum side of the turbo so that we can monitor the electric vacuum pump to see whether it's supplying vacuum to this thing during the event or not. So just give me a second here. I'm going to switch the vacuum hose over, and then we'll road test it again and see if the pump can actually maintain vacuum during the event. So we've now got our vacuum pump hooked up on the vacuum pump side of the solenoid. Let me get it into view here so you can see it. And you can see we're kind of getting the same reading here. Now I don't like the fact that the vacuum is low here. I'm not sure whether that's a bad pump or not, and it's kind of bouncing around quite a bit as well, which is sort of unusual for an electric vacuum pump. But what we're going to do is we're just going to take the car out, and we're just going to hammer it and watch. Whoa, there the solenoid just tripped. And now that the wastegates are blocked off, look how much vacuum this pump is making. So it looks to me like we definitely have a leak on the turbocharger side of the vacuum control solenoid. And just to be clear what's happening here, when the code sets, the computer shuts the solenoid off and then we can see how much vacuum the pump is actually producing. So we've got a leak on the turbocharger side of the solenoid. So to wrap this one up, we took the car back to the shop, and unfortunately I forgot to shoot video of us testing it. But what we did was we tested the vacuum hoses and the two wastegates on the turbochargers for leaks. And what we found was the vacuum diaphragm on the driver's side wastegate actuator, so the vacuum pot, had a hole in it. It wouldn't hold vacuum. We couldn't suck the turbocharger wastegate to the on position. So basically what's happening is the left side turbocharger isn't producing any boost, and the right side turbocharger, because of the leak on the left side, the computer is not able to control it. Bottom line, this thing's going to need a left side turbocharger to fix it. And yeah, so that was kind of an interesting one. Didn't turn out to be too bad in the end, but left side turbocharger wastegate was the culprit on this guy. If you like this video, please let us know by following us or liking us on Facebook, Instagram, Twitter, and YouTube. And if you want access to more in-depth training videos, please visit our website at www.autoaide.ca. Thanks for taking the time to watch this video.